This is an introduction to the FortiGate unit and the Unified Threat Management, or UTM, features it has. We'll start out by talking about the major features of the FortiGate unit, and then we'll go over the access management functions. For the next 30 minutes or so, we'll be talking about various things. Some of the other products available from Fortinet, a few of the features that are available on a FortiGate, dealing with administrative access, users and their security profiles, our FortiGuard subscription services, the modes of operation, what the default settings are, doing a configuration backup and restore, the proper procedure to upgrade and downgrade a FortiGate, and the console port. We will be covering a few other topics as well, but these are the primary points. By the end of this module, you should know the major features of a FortiGate, be able to manage administrative access to the device by modifying access restrictions, managing administrative users as well as their access profiles, be able to back up and restore a configuration file, set up a DHCP server, and upgrade or downgrade the firmware. A FortiGate unit is a unified threat management device, but what exactly does this mean? Well, if we look at a typical network solution, it is made up of multiple single-purpose devices, each performing a specific task. There is one device acting as the firewall, another device providing virus scanning, another device filtering email, one device to deliver WAN optimization, another device filtering websites, one device for your application control, one device for the intrusion scanning, one device dealing with the VPNs. That is a lot of different devices doing so many different things, and most likely these services are being provided by multiple vendors. All of this can introduce many points of failure to your environment. A FortiGate unit, however, combines all of this and more into a single device. This way, you only need to access one device, and you can make changes to every aspect of your network and security deployment. Furthermore, these security offerings are based on in-house technologies which do not rely on any third-party vendors. The FortiGate unit provides a comprehensive approach to security. Let's have a brief look at the unit's design approach. What you have is purpose-built hardware, the FortiASIC chip. Obviously, this layer does not apply to virtual machine devices. The next layer is a hardened operating system. The security components and network services lie over the operating system. Finally, there are the FortiGuard subscription services that can be used as well. As you can see already, a FortiGate unit is much closer to an actual computer than it is a traditional firewall appliance. So the big question is then, what can a FortiGate appliance actually do? Let's look at some of the functionality it can provide. This is a rather large list. Keep in mind, this list is not comprehensive. A FortiGate unit can act as your firewall, scan for viruses, filter your email, filter your web traffic, scan for attacks, identify your network traffic, prevent data from getting leaked out of your network, optimize your WAN traffic, handle IPsec and SSL VPNs, manage your wireless controllers, provide both static and dynamic routing, enforce endpoint compliance, manage virtual domains, enforce traffic shaping, can be configured for high availability, provide extensive logging and reporting, and it can provide different types of user authentication. It's a long list, isn't it? As I mentioned, these are only just some of the major capabilities a FortiGate unit offers. The icons in this picture would need to be much smaller if it were to include every feature. Fortinet also offers many other devices which are purpose-built, meaning they only have one particular task, unlike a FortiGate unit which is a multi-purpose UTM appliance. A FortiGate device works closely with the FortiAnalyzer unit, which provides long-term logging and reporting, and the FortiManager unit, which also allows easy manipulation of multiple FortiGate devices at once, as well as some long-term logging and reporting capabilities. It also links with a FortiAP device to provide wider wireless coverage ranges. The FortiGate unit also has hooks for interfacing directly with FortiClient to offer some different features which will be covered in later modules. The only difference between a FortiGate unit and a FortiWi-Fi of the same model, for example, a FortiGate ADC and a FortiWi-Fi ADC, is that the FortiWi-Fi version has a built-in wireless card. There is something to keep in mind with all of this, and that is properly sizing your device. If you size a FortiGate appliance based on it performing just one function, then you will limit yourself because there will be a lot of other features available that you will not be able to use if you do not have the correct CPU or memory requirements. While the FortiGate can do email filtering, it is a firewall. As such, the capabilities it has are limited when you compare it to something like FortiMail, which is specifically designed to filter email and can act as a relay, unlike the FortiGate. So it's important to remember to select the right product for the job. The FortiGate unit also has a global FortiGuard subscription service that can be used. This service provides updates to the antivirus and IPS databases. These two features are static services with a database that updates periodically. There is also a live service available for the web filter and anti-spam components that is separate to the periodic AV IPS updates. This service requires a live, constant connection to the FortiGuard distribution network in order to function as well as a valid contract. There's a short grace period after the contract expires before these features will stop working. AV and IPS scanning will continue to function without a valid contract, but the databases will not update, which means their effectiveness will decline over time. For the live connection or database update, the FortiGate makes a connection to the FortiGuard distribution network. Preference will be given to the nearest server, but the FortiGate unit can obtain its updates from any server available within the network worldwide if the local servers are busy. If it's set up, these updates can come through a FortiManager instead. When you deploy a FortiGate, you can set it up to operate in one of two modes of operation: NAT or transparent. NAT mode is the easiest to explain. The device operates on layer 3, so each interface has an IP address and it handles packet routing like a typical router would. Transparent mode is different. The device operates on layer 2. The unit really doesn't handle routing at all when it's in transparent mode. This is a copy of the 7-layer OSI model. NAT mode operates on layer 3, so it sends packets around based on the IP address. Transparent mode is layer 2. This means the IP doesn't impact where the packet is sent, and it's looking for MAC addresses. Transparent mode can be a complicated method of deployment, but can be advantageous as you would not be required to make any changes to existing network topology. Transparent mode is discussed in more detail in our transparent module. Every FortiGate FortiWi-Fi device has the same default setup. Port 1 or the internal switch, depending on your hardware, will have an IP address of 192.168.1.99 on a /24 subnet with ping, HTTP, and HTTPS access enabled. There will also be a DHCP server on that interface for almost all of the models, so you can easily get an IP. The default username for login is admin with a blank password. Both the password and username are case sensitive. When configuring your device, you should remember to change the admin logging information because the default setup is publicly available knowledge. Your device is only as secure as your admin users, and if you do not alter the default information, all the security in the world will not help you. Now we start talking about a more interesting part of this section, that is the practical administrative side of a FortiGate unit. There are two ways of administrating a FortiGate unit. The primary method is to use the GUI. You can also use the CLI by accessing the CLI Java widget from the status page, the console port, and SSH or Telnet if they are enabled. Note that anything you can perform in the GUI can also be done using the CLI. The reverse, however, is not true. Some functions are only available in the CLI. Generally, these are more advanced and expert-level options that are not commonly needed. The FortiGate unit was primarily designed to have the bulk of its configuration done through the GUI. The CLI is mainly meant for fine-tuning, tweaking the configuration, and running diagnostics. The GUI design layout is pretty straightforward. Once you log in, you will see all the menu and submenu options listed along the left-hand side, with the main part of the window containing the configuration options for the selected menu item. Once you log in, you can create a new administrative user. You can have different types of administrative users by customizing their profiles. Within the configuration settings for your administrative user, you can see here where you can attach, assign their profile. The admin profile is what determines their access level. In other words, it is what applies restrictions to those user activities on the FortiGate. You can change the administrator's permissions by altering their administrative profiles. Profiles can be customized so that users can have different permissions set for different aspects of the device. Read-only, read-write, and no access are the three possible options for each setting. The super admin is the default profile for the admin user. It is built-in, cannot be changed, and provides the user with full access to everything. Prof admin is a default profile the unit comes with as well. By default, this profile provides full access, but it can be modified. You can also create new admin profiles as well. You can have many different types of users on the FortiGate device. A lower permission level cannot create or even view administrative users that are a higher level, so a prof admin or custom profile administrator can never create or modify a super admin user. Actually, they would never even be able to see a super admin user even exists. Lower permission users cannot see any higher permission users. Another way to make your administrative users more secure is to use the Trusted Hosts feature. This feature does exactly what it says in the GUI. It restricts the user so that unless you are connecting from one of the listed trusted IPs or subnets, then you will not be able to log in to the FortiGate unit. Even if you know the correct username and password to use, if you are not coming from one of the allowed IPs, you will be denied access. This is useful because even if your user's login information is compromised, the login will only be permitted where you specifically allow it. One side effect of this is that if you set up trusted hosts for all of your admin users and they try to connect to the unit from an IP not allowed to connect on it by any users, the FortiGate will not even respond. This applies to all management traffic, HTTP, HTTPS, Telnet, even ping to an interface. The idea here is that if it is not possible for you to log in, resources will not be wasted responding. This also helps prevent inadvertent discovery and identification that you have a FortiGate device within your network. You can also make use of other devices like a FortiToken so that administrative users are forced to use two-factor authentication. Two-factor authentication just means that instead of using only one identifier in order to confirm access, a password for example, you use two identifiers. In this case, a password and a randomly generated number. There are a couple of different ways of providing two-factor authentication for an administrative user. The first is to register and use a FortiToken device. A FortiToken device is simply an RSA key generator that is synchronized with the FortiGate unit. Optionally, the FortiGate unit can send an email or an SMS text message. The email address that is used to send is configured here in the GUI. The mail server can be configured under System, Config, Messaging Servers, or in the CLI. Details to use for the SMS are configured from the CLI only. You simply need to enter the administrator's phone number in the GUI. The details required for routing the message to the administrator's phone will need to be obtained by their cellular provider. Now that we have covered the mechanisms for accessing the FortiGate device, let's talk about the unit's configuration aspects. Everyone would agree that configuring a security device is not a small concern. A properly configured device takes careful planning and consideration for many different elements, all working together to secure and make your network operational. Device configuration files can be encrypted with a password if necessary. Besides providing you with some additional security by encrypting your configuration, it also does other things that you might not expect. Once encrypted, the configuration file cannot be decrypted without the password and a FortiGate unit of the same model and firmware the backup was created on. Anytime there is encryption of any sort involved within the configuration file, the algorithm encrypts, hashes, and salts the output. Even if the configuration is not encrypted as a whole, all passwords always are. Keep this in mind when working with the Fortinet support team and you try to send them an encrypted configuration file. To be able to read anything in your encrypted configuration file, they would need to track down the same device as yours, which could cause unnecessary delays in resolving your ticket. If you open the configuration file in a text editor, you'll see that both encrypted and unencrypted configuration files contain a clear text header that also contains some basic information about the device. To restore an encrypted config, you will need to do so on a FortiGate that is the exact same model running the exact same build, as well as you know the encryption password. For an unencrypted config, it only needs to match the exact model. When you use an unencrypted config on a FortiGate that is the same model but a different firmware, it acts like an upgrade and tries to convert it, so it follows the same limitations as if you were upgrading the firmware. A configuration file only contains non-default settings as well as settings that would be vital in the event of a restore. This helps keep the size down, otherwise even a basic configuration for a low-end device would be a text file that was several megs in size. Configurations can be backed up and restored on a per VDOM basis if you have them enabled, not just for the whole device. A VDOM is a virtual domain. It's like splitting the FortiGate appliance into multiple virtual units. VDOMs are covered in more detail in our VDOM module. Once you have access to your FortiGate unit, it's time to set it up and configure the network interfaces. When the FortiGate device is in NAT route mode, every interface that will be handling or passing traffic must have an IP address. This can be managed in one of three ways, including static IP, DHCP assignment, or PPPoE. There are two other modes available, one-arm sniffer and dedicate to FortiAP. There is a wireless course that will go into detail on the FortiAP. The one-arm sniffer can be configured in the GUI and CLI. For the purpose of this course, we will only be using static assignment. Once you have an IP address on an interface, you can select the methods for allowing administrative access. These are things like SNMP monitoring, GUI, and CLI access, if the interface will respond to pings or not, settings of that nature. IPv4 and IPv6 management settings are different, so it's possible to have an interface that has both an IPv4 and IPv6 IP, but only respond to pings to one of those IPs. IPv6 will only show up as a configurable option if the feature is enabled to show up in the GUI. This leads to our next point. For the GUI, you have some options in what features you do and do not see. The FortiGate has hundreds of features. Many of them are only configurable from the CLI, but some of them have the option of being in the GUI or hidden. If they are hidden from the GUI, they are not disabled, it simply turns off the ability to configure that feature from the GUI. The primary features you can hide and unhide using the Features widget on the dashboard. This allows you to have the FortiGate act as a firewall in one of several different configurations. The widget only shows the primary features that can be hidden. For a full list of features that can be hidden and unhidden from the GUI, you'll need to go into the Features menu and click Show More. The Features widget has a couple of bulk preset options in regards to features you wish to hide from the GUI. The first is NGFW. This stands for Next Generation Firewall. A next-gen firewall is one that offers line speed inspection with no slowdown of the traffic. Setting up the unit this way will hide all of the UTM options that cannot be used without potentially slowing down the traffic. ATP stands for Advanced Threat Protection. This enables options that focus on providing protection for computers. WF is for Web Filtering. As the name indicates, this applies only to the options that revolve around filtering websites and hides others. The next option, NGFW plus ATP, is not described in text. That is because this option simply has all the options from both NGFW and ATP show up in the GUI. Finally, there is the full UTM preset. All of the available UTM inspection options show up in the GUI. You can also customize the ports that administrative access will use by changing the ports for those services. For better security, it is always best to only use secure, encrypted methods of access. So HTTPS and SSH would be the most secure methods to use. You can also decide if you want to allow multiple concurrent connections from a single user or not. In order for the firewall to be able to do proper routing, you will need to have a default route. If an IP address is being obtained through a dynamic method, then the default gateway information can also be retrieved automatically. Otherwise, a static gateway will need to be configured. Without this, the unit will not be able to respond to packets outside the subnets on its own interfaces. It will also be unlikely to be able to obtain its own updates and may not properly route the traffic that is passing through it. Routing will be covered in more detail in an upcoming module. A FortiGate unit can be configured to act as a DHCP server. To do this, select the interface and enable a DHCP server on it. Once you enable DHCP on that interface, you can manipulate the settings for it. You can set up IP reservations for specific MAC addresses, so those devices will always be issued the same IP from the DHCP server. You can manually set up the MAC address or select a MAC from the list of clients that have already connected to the DHCP server and been issued IPs. DHCP activity shows up in the event log in the router subsection. You can find detailed information about the MAC addresses and IPs by looking in the log details or by looking in the DHCP monitor, which you can also find in the system menu. The FortiGate unit itself can also be configured to act as a DNS server. This allows you to point your internet devices to your FortiGate unit for hostname resolution. Depending on which behavior is required in your environment, one of the three available methods can be used for handling DNS requests: forward only, non-recursive, or recursive. The behavior of the DNS configuration on each interface can be set up separately. Not every interface needs to be acting as a DNS server. Even if they are, they do not need to behave the same way. This feature is only available from the CLI unless you enable the DNS Database setting. Another feature of the FortiGate is to do DNS forwarding. You can configure each interface for how you want it to treat DNS requests that are directed at it. This allows you to give a great deal of control over the DNS within your own network without having to set up a separate DNS server. If you use Resolve or have a split DNS setup, you will need to set up a DNS database on the unit so that it has the host names built into its configuration. Zone files must be configured, and your syntax will need to follow the format outlined by RFCs 1034 and 1035. Upgrading the firmware on a FortiGate is quite simple. The easiest method is from the GUI on the status page in the System Information widget and clicking the Update button. In order to make sure your upgrade goes smoothly, any kind of firmware upgrade is always a 6-step process. Step 1. Backup your old configuration. The GUI doesn't do a full backup, just the changes that you made to default settings. This is to help keep your configuration file size down. But just to make sure that you don't lose any information, use the backup option from the CLI and do a full configuration backup. Step 2. Make sure you have a copy of your old firmware available. The FortiGate can convert the configuration between different builds, but in order to minimize risks, it's best to have the exact same version you were running on hand. Step 3. Make sure you have a disaster recovery option on standby. The FortiGate is a security appliance, so if anything goes wrong in the upgrade, there is no backdoor. It's the console port. This doesn't mean you need to be on-site to do an upgrade, but it means you'll need to be aware that you might need to get on-site or get someone on-site if something goes wrong. Step 4. Read the release notes. They contain upgrade and downgrade information as well as any special information you may need to be aware of. They also contain information about known and resolved bugs, so it's worth taking a look to see what you're getting into. Step 5. Double check everything. Open up the config file to make sure the data is there, double check the file details on the firmware copy you have, make sure about the option of physical access, read the release notes a second time to see if there's anything you might have missed. Step 6. Perform the upgrade. Remember, this device does not have backdoors, so if you are doing this from remote and you lose access, your only option to find out what happened is to get physical access, so keep that in mind. Downgrading the firmware is also possible. You will need your old configuration file. One thing to remember is to read the release notes. Sometimes a downgrade between firmware versions is not even possible, like if the operating system changed from 32-bit to 64-bit. If this was the case, then the upgrade release notes would have mentioned it, so that it should not come as a surprise. In that situation, the only way to downgrade will be to format the unit, which we'll cover on the next slide. Once you've determined the downgrade is possible, double-check everything and run the downgrade. After the downgrade is finished, you'll be able to log in and restore the configuration backup that you made before the upgrade. When you do a downgrade, you will lose everything in your configuration except what you need in order to get access to the unit, so things like IPs, interface settings, and admin user details. This should not be a problem because in the previous slide, the upgrade procedure involves backing up the configuration, which you can then restore. The last thing we'll talk about is our last resort backdoor user called maintainer. This user is on all FortiGate devices and even some not FortiGate devices like the FortiMail and such. It's a user that's only available through the console port and only after a hard reboot, a physical power cycle. A soft reboot, like issuing a reboot command through the CLI, won't work. The unit needs to be physically shut off and turned back on in order for this to open. That's the difference between a hard boot and a soft boot. Even then, it's only available for login for about 30 seconds after the boot up completes. The user is maintained all in lowercase. The password is BCPB and then the unique serial number of the device. Any letters in the serial number are capitalized. If you have issues with the physical security of your device or have compliance requirements, it's possible to turn off this user in the CLI. However, if you do this and you lose your normal admin passwords, there is no way to recover it. All FortiGates have a console port. On some models, it's a serial port. These would be our older devices. If it's a serial port, then a standard null modem cable can be used to connect with. On other models, it's an RJ45 port, a network jack. If that's the case, then you need to access by using an RJ45 to serial cable. You can't access it over a standard network cable. Other models, the console port is actually a USB 2 port. In that case, you plug the cable into your PC and you can connect using FortiExplorer. Each device ships with a console cable that you can use to access that device and any other device that uses the same method of access. Serial ports on computers are getting uncommon these days, so if you have one of the first two varieties, you can also pick up a USB to serial converter in just about any computer shop. For any device with a USB 2 port and no RJ45 or serial console port, the only way to access the console port is through that USB 2 connection using FortiExplorer. For most other devices with a USB, you can connect with FortiExplorer. The PC and Mac version of the software allows you complete configuration control since you can access both the GUI and CLI. The version for iOS is really intended just to set up IP and routing options to get a new unit up and running in environments so that it can pass traffic and you can access it to do real configuration. It's great because you don't need to pre-configure the firewall when you put it into a data center or bring bulky equipment. Simply cable it up, then plug in your phone or tablet and set up the IP details. Now it's time for the labs. The first lab is simply about getting used to the FortiGate, working with the CLI a little, setting up interface IPs, and working with configuration files. The second lab is optional, and it's all about limiting management access to the unit. The initial lab is pretty short, so you have 10 minutes to complete it. If you finish the first lab, go ahead and move on to lab number 2. This is a look at the topology you'll be using in the lab. The machine you will be working from, your landing machine, has an IP address of 10.0.1.10. You will also have access to two FortiGate units whose IPs are 10.0.1.254 and 10.200.3.1. The two FortiGate devices are called student and remote. If the lab requires you to connect to any of these devices, instructions will be provided in your student lab guide. In this module, we will look at the logging and monitoring aspect of the unit. Since you are implementing a security solution, it is important to be able to properly keep an eye on the FortiGate unit's operation. It is vital to have this aspect of your configuration set up properly and for you to be able to read the output. Otherwise, the FortiGate unit will operate as per its set configuration, and once issues are encountered, the proper logging will not be there to help find out clues to what may be happening or why. Some of the topics we'll be covering include going over the different severity levels, possible log storage locations, different kinds of logs, the structure of the logs and behavior, the traffic log, how to view log messages as well as how to read them, setting up alert emails, and a lot more. By the end of this module, you'll know what the overall purpose of different types of logs are, be able to identify logs that are stored, navigate through various screens in the GUI to do logging and monitoring, read the log messages to obtain information, and set up filters. Logs can help you monitor your network traffic levels, track down problems, establish baselines, and a lot more. Some organizations even have legal requirements when it comes to logging. It would probably not be practical to block other administrators from making changes to your FortiGate unit. When changes are made, however, you would want to know about it. Log files can tell you what someone did or what is happening on the device so that you can make adjustments if you need to. Depending on the log entry, it will have a different level. The levels range in order of importance from debug to emergency. Debug will put additional information into the event log and is worthless unless you are actively investigating something. Obviously, these additional logs will require additional resources to create. Generally, the lowest level is to use information. Debug is only needed to log diagnostic data and will put more strain on the CPU resources. Who decides what needs to be logged? You do. Well, let's be honest. Your business requirements dictate what kind of activity needs to be logged. Logs can be stored in a variety of places, both on and off the device. Locally, you have memory, and many devices have a built-in hard drive. Externally, you may have syslog servers, FortiCloud, SNMP, or a FortiAnalyzer device. A FortiAnalyzer or FortiManager is just an IP for the FortiGate to communicate with. It can be within the same network or not. The FortiAnalyzer or FortiManager has a list of devices that it will allow to communicate with. So long as the FortiGate has properly registered, the FortiAnalyzer or FortiManager will accept incoming logs. Communication between the two devices is done via SSL encrypted OFTP traffic. When a log message is generated, it can be safely transmitted across an unsecure network. In terms of logging, configuring the FortiGate to use a FortiAnalyzer or FortiManager is absolutely identical. The difference is when you compare their capabilities. They can both take log entries, but a FortiManager's primary purpose is to centrally manage multiple FortiGate devices. As such, it has a limit imposed on the amount of logs it can receive in a day. What you can do with the logs that have been received on a FortiManager is no different than what you can do with a FortiAnalyzer. Configuring logging to a FortiAnalyzer or FortiManager is the same regardless of the device. You can do it in the GUI under Log and Report, Log Config, Log Setting. If you go into the CLI, you can configure up to 3 separate FortiAnalyzer or FortiManager devices. The option in the GUI only relates to the CLI equivalent config log FortiAnalyzer setting and not numbers 2 or 3. You may need a setup like this for redundancy or some other requirement. Keep in mind that generating logs requires resources. How much sending to multiple locations like this will impact your resources depends on how many logs you're creating. Another external logging option is to use FortiCloud. This is a subscription service offered by Fortinet that offers long-term storage of logs and reporting functionality. It's a similar idea to FortiAnalyzer, but meant more for a smaller setup where purchasing a dedicated appliance isn't feasible. Every FortiGate comes with a free 1-month trial. All you need to do is activate it from the GUI and link it to your FortiCare user and start sending logs. Be sure to read any documentation on the website if you are considering this option. On the FortiGate, all the logs are split up into 3 different types. You have your traffic log, your event log, and your security log. They are each split up into subtypes. Traffic log contains forward, local, and invalid. The forward log contains information about traffic that was accepted or rejected by a firewall policy. Local traffic is traffic directly to or from the FortiGate, logging into the GUI, FortiGuard queries, those type of things. Invalid packets are the ones the FortiGate unit throws away before they even get to a firewall policy. Within the event log, there are a bunch of subtypes. System event are things that relate to system operations. Automatic updates of the AV IPS definitions, people logging into the GUI, router, VPN, user, etc. These all contain log entries related to that feature. Router would contain BGP or RIP log entries. VPN would contain IPsec and SSL VPN log entries. User would contain log-on, log-off events for people hitting firewall policies, that sort of thing. Finally, there are the subtypes for security logs. Every security profile will create log entries of that type: antivirus, web filter, etc. This section will only show up if logs have been created within it. When you check the Log and Report section of the FortiGate GUI, you will see the three sections for logs. They correspond to the three different types of logs. The traffic log logs events about packets. Event logs keep a record about things like admin users making changes to the configuration. Security logs come from security profiles being activated on your firewall policies. By default, most of the security events will show up in your forward traffic log. This is for performance reasons, as fewer log files are easier to maintain than more. The exception to this is DLP and intrusion scanning. Events for these always show up in the security logs section. Some of the profiles can be modified in the CLI in order to obtain additional log options. If you go into the CLI of an antivirus, web filter, email profile, you'll find an option called UTM-extended-log. If you enable it, then some additional logging options will be available to you in the CLI. In addition to that, security events from the profile will now show up in their own section under security logs. This is just a chart to show what the expected behavior will be when you enable different logging options. This first column is for the log setting of the firewall policy. This second column is if an antivirus, web filter, email security profile is enabled. As the previous slide showed, DLP and IPS profiles always generate logs in the security logs section. The third column is for that CLI option discussed on the previous page, extended-UTM-log. If you have any profiles enabled on your policy and logging is not enabled on the policy, then you will not get logs of any kind, even if the profile was configured to block the traffic. So if you apply a security profile, it's important to remember to consider this setting. The following shows the FortiGate unit's GUI when you are inspecting the logs. In the Windows upper right corner, you have the option to switch between viewing the logs from different locations if the FortiGate is set up to log to multiple locations. Having your firewall configured to actively inspect your traffic and not make a log entry about it is not recommended. You can also set up various filtering for the logs so that you see specifically what you need as opposed to being confronted by a massive wall of log entries. The more information you can specify in the filter, the easier it will be to find the precise log entry you are looking for. Filters are configured for each column of data that you will choose to display. By default, only a subset of the information is displayed in the GUI. More can easily be added in order to make finding the data you need easier. The overall layout for a log message is that it has two sections, a header and a body. The header will have the same layout for every log type and subtype message. The body will change from one type of log message to another. This is because there is some data that will be common to all logs, like a date and time, while the type of event that's being logged will dramatically change what needs to be recorded. This is an example of a raw log entry. As you have seen, the GUI produces a more structured view of the log entry, making it much easier for someone to read. The severity level of the log is located in this level field. If you log to a third-party device, such as a syslog server, you will need to know how to set up your filters in order to find what you need. You can find a document that contains all the logs and their layouts from the Fortinet Docs website at docs.fortinet.com. The header can be used to identify when the log was made, what type of log it is, the level, and so on. These attributes that are common to every log are located in the header. It could just as easily have been a traffic or event log, but then the type and subtype fields within the header would have been different. Obviously, if it had been a different type, the information contained within the body would have been a different format as well. The body can be used to get the specifics of the log message and what actually happened. The value, indicated by policy ID field, which is 100 in this case, shows which firewall rule was used. Since the administrator should know their configuration, this should provide them with useful information about the traffic, since it will point them to the policy that this traffic passed through. Also important to see in the log is the action taken by the FortiGate unit when it encountered this traffic. We can see here that the status is deny, which means the FortiGate prevented this particular piece of traffic from passing. Rather than look at the logs from the GUI, you can also display log messages from the CLI. This allows you to set up a number of filters on the logs that are displayed and capture the output to a file and send it via the options you specify, such as FTP. Alert emails are like getting a paging alert. The idea is that if you are not physically on the device, you may want to get notified about certain things so that you can fix them, hopefully before anyone realizes there was even a problem. Alert emails are set up similar to any log device. First you decide what is going in them, a filter, and then where it is going. In order to set up an alert email, the first thing you need to do is configure an SNMP server that the FortiGate will talk to. If you don't set this up, the alert email option will not show up in the log and config menu. Once you set up an SNMP server, you can configure your alert email settings. Another option that's related to logging is the alert message console. This is a GUI widget. It's a similar idea to alert emails, but messages will show up in the widget when you log into the FortiGate. Events show up as a list like this. Each one can be separately acknowledged, and it won't show up anymore. The idea is that these events are potentially things you should look into. It's good to know that something has occurred, and you should check to confirm it is still working. Once you confirm that the event did not impact anything, you acknowledge it, and it gets removed from the list. You can edit the widget in order to set up what sort of events will show up in the widget as alerts, how many alerts it will display, as well as the name of the widget. You can have multiple alert widgets on the dashboard with different names, all displaying different kinds of alerts. Another method of monitoring a FortiGate unit is to use an SNMP device. The MIB files are located on the support website and can be loaded into any SNMP software so that you can set up automatic queries to the unit in order to find out the operational status. They are also downloadable directly from the FortiGate's GUI. You can obtain everything from CPU and memory levels to what the cause was for the last spam detection. A FortiGate device can support SNMP versions 1, 2, and 3. Setting up the necessary SNMP options is fairly straightforward from the GUI. Simply enable and define the service as you would any other SNMP monitor device, and then enable your protocol options and methods of monitoring. What can be monitored with the different options is exactly the same. SNMP version 3 offers some additional security over the previous two versions of the protocol, like traffic encryption and authentication. Setting the overall log settings in the GUI is fairly straightforward. Under Log and Report, Log Config, Log Settings, you can enable different locations you want logs to be stored. You also have the option to adjust the different kind of traffic that will show up in the local traffic log. Finally, you have some GUI options you can adjust. Resolving IPs to host names will require that the FortiGate does DNS lookups for all the IPs. If your DNS is not working or running slowly, this can impact your ability to look through the logs, as the requests will all need to time out. From the CLI, you can configure more options than the GUI. You can set up to 3 separate FortiAnalyzers as well as up to 3 syslog servers, which are options that are not available in the GUI. There is also the ability to set up logging to WebTrends, which is a third-party service. Depending on which option you configure, you'll need to set up different information like the location IP, a username, or something of that nature. The firewall policy itself also has logging options in it. The way it works is that the policy setting is what determines if and when a log message will be generated for traffic passing through that particular firewall policy. The settings you find under Log Settings in the GUI and under Config Log in the CLI determine where the FortiGate will store the log messages it creates. The event log provides all of the system information generated by the FortiGate unit. This may include administrator logins, configuration changes made by administrators, user activity, and daily operations of the device. In your log setting area, you can enable which events you want to log. What you enable for logging depends on what features you are making use of and what information you need to get out of the logs. None of the event logs that are created are caused by traffic passing through firewall policies. VPNs going up and down, routing protocol activity, those sort of things are not caused by anything passing through a firewall policy. One exception might be the user log. This doesn't record information about traffic through firewall policies directly, but it does record user log-on and log-off events on traffic that passes through policies. There's also a daily log monitor section. This will tell you how many logs the unit has generated over time and what type they are. It makes it easier to see where the FortiGate unit is spending the most resources and if any trends are occurring. You can drill down these logs by clicking any of the days in order to get a more detailed look at how many logs were generated. Each function of the FortiGate unit has an equivalent monitor menu item in the GUI. This allows you to take a look and see how at any given moment in time the feature is performing. The security functions have a monitor option like the rest, but you need to enable it from the CLI before it shows up. With a lot of security activity, this could impact your CPU, so it's disabled by default. One example is the Security Profiles monitoring section. It has subsections for each security feature to highlight recent activity to give you a snapshot of what is happening with that option. Pretty much every menu has this option: VPN, user and device, etc. Another means of monitoring is to use the widgets on the status page. Many of them can be customized to show the same type of information, but in multiple ways. If you click on the little pen in the upper right corner of the widget, you'll be able to adjust any of the available settings for that widget. Some widgets can be added multiple times to the same dashboard. Each instance can display different information. This is just a look at the options available for the Top Sessions widget. By default, there are a number of different dashboards that are available. Each one has a different name with a different collection of widgets set up to provide different types of information. Each user has their own dashboard setup and layout, so if one user deletes a dashboard and rearranges the widgets on the status page, it will in no way impact any of the other users. You can alter a user's permission not to allow them to make changes to their dashboard and use this to restrict their access. There is something in the CLI called a crash log. This is not a place that stores log messages. It's used purely for diagnostics. The FortiGate is like a computer with different processes that handle different things, like DHCP or web filtering, for example. Anytime a process is closed for any reason, the crash log records this as a crash. This way, if there is an abnormal termination of a process, the programmers can look into it and find out the condition that caused it. A normal and fairly common thing to see in the crash log would be entries for scan unit D, which is the process responsible for virus scanning. Anytime the definitions package is updated, that process needs to close down, apply the new package, and restart. It is a normal shutdown, so you will see an entry like what is listed here for scan unit with status equals 0, which indicates it was a normal shutdown with no abnormalities. Now it's time for the labs. The initial lab will have you exploring the GUI of the unit. Exercise 1 deals with the status monitor. Exercise 2 will cover the event log. If you finish the first lab, go ahead and move on to lab number 2.